Hello, good day viewers. In this tutorial, we are going to find a solution to this interesting equation, which is x to the power 4 equal to 1. Because the equation is of degree 4, therefore we expect 4 solutions. So let's start with method number 1. For method number 1, I would like to subtract 1 on both sides. So we have x raised to the power of 4 minus 1 equals 0. So this can further be rearranged as x squared whole squared. This is the same thing as x to the power of 4 minus 1 is the same thing as 1 squared. This is equal to 0. Now we have difference of two squares. What can you remember about difference of two squares? If I have a squared minus b squared, this is the same thing as a minus b multiplied by a plus b, right? So we are going to apply the same principle here, for which x squared is our a and 1 here is our b. So we have x squared minus 1 multiplied by x squared plus 1. This is equal to 0. We can rearrange this as x squared minus 1 squared for the first factor, and for the second factor we can write it as x squared minus I squared. I will explain this. From this, you can write it as x squared minus 1, because minus minus is plus, so we get this plus back. But 1 negative is the same thing as I squared, so this becomes x squared minus I squared. I squared here is negative 1, so therefore it can be written as this. Let's continue. Another difference of two squares here, which can be factorized as x minus 1 multiplied by x plus 1. Another difference of two squares, that is x minus I multiplied by x plus I equals 0. Now we have 4 factors. We are going to set each to be equal to 0. The first one, x minus 1 equal to 0. It implies what? X must be equal to 1. This is our first solution. Second one, x plus 1 equals 0, which implies x has to be negative 1. Third solution, x minus I equals 0, which implies that x has to be positive I. The last one, x plus I equals 0, which implies that x has to be negative I. So we have 4 solutions. X could be plus or minus 1 or plus minus I, and you can test them in the main equation to see whether they are going to satisfy or not. Let's take the second method. Method number 2. Remember that from Euler's formula, e to the I pi plus 1 is equal to 0, which implies that e to the I pi is equal to negative 1. So how can we transform negative 1 into positive 1? Because the right hand side of our equation is positive 1. Once you raise a negative number to an even exponent, it will be positive. So the moment you raise negative 1 to any even number, it could be 2, 4, 6, whatever, it will be positive 1. So we are going to raise both sides to an even exponent. An even exponent, even number, is defined by what? 2n, for which n is just a positive integer. Therefore, we can say that e to the I pi raised to the power of what? 2n or 2k is equal to negative 1 raised to the power of the same 2k, for which this is just an even number, which is going to transform this into a positive number. So this can be expanded as e to the 2I pi k equals 1. So instead of this 1, we can now replace it with this one from our original equation, which is what? X to the power of 4 equal to 1, remember? So therefore x to the power of 4 can now be written as e to the 2I pi k. Since we are looking for x, we can divide both exponents by 4, and hence x is equal to e to the 2I pi k divided by 4. And the 2 here will go into 4 exactly 2 times. So x finally equals e to the I pi k divided by 2. And you know that we can express this in polar form. Let's do that. X is equal to cosine of this, which is pi over 2k, pi over 2 multiplied by k, then plus I sine of the same thing, pi over 2k. So let's start substituting the values of k. When k is equal to 0, we have x to be equal to cosine of 0 plus I sine of 0, because 0 times the whole of this will give us 0, right? And what is cosine of 0? Cosine of 0 is 1. Sine of 0 is 0. So the whole of this will be equal to 1. First solution. And second solution is when k is equal to 1. When k equal to 1, you see that 1 times pi divided by 2 will still be pi divided by 2. So x equal to cosine of pi divided by 2 plus I sine of pi divided by 2. And what is cosine of pi divided by 2 is equal to 0. Sine of pi divided by 2 is equal to 1, and 1 times I is I. So we have I here, which means that x is equal to I. Second solution. Third solution, when k is equal to 2, the moment you multiply this by 2, it becomes pi. So we have a x to be equal to cosine of pi plus I sine of pi. And what is cosine of pi? It is equal to -1 plus sine of pi is 0. So 0 times I is 0. So x equals -1. Third solution. Then the last solution is when k is equal to 3. What are we going to have? We're going to have 3 times pi divided by 2. That is 3 pi divided by 2. So x will be equal to cosine of 3 pi divided by 2 plus I sine of 3 pi divided by 2. Cosine of 3 pi divided by 2 is equal to 0. So this is 0 plus I multiplied by sine of 3 pi divided by 2 is -1. So we have I times -1 is -I plus 0 is still -I. And hence x equal to -I. And this is our fourth solution. You can see that x could be -I, -1, I, or +1, the same thing as the previous solution, which are this. Thank you for watching. Do share to your learning colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.